Hello everyone, welcome to the session on Genius Chalk, and I hope you all are good. So let's proceed with the next part of number system, which is part number 10. And if you have not watched the previous parts, please go through the previous parts as we are discussing important previous year questions, whether you are preparing for bank exams, whether you're preparing for any state exam where aptitude is asked, or if you are preparing for any other exam like SSC, right? So this is important for all the uh, exams where the aptitude is asked. So let's proceed with the first question. So guys, the first question says, what is the unit digit in this? So always remember the rule. What is a unit digit? Unit digit means we are just considered about the last place. The last place, right? What is the last place? Like this is unit place, right? Or you remember this like ones place. Whenever we write a number like ones, tens, like this, so this is called ones place, this is called tens place, this is called hundreds place, this is called thousand place. Suppose I write 4, 3, 6, 9. Here 9 is called the unit digit, right? This is the unit digit, and this is also called ones place, and this is also called further unit digit. So we are interested in finding the answer of this question where powers are also involved. Okay, so let's try. 568 to the power 377 minus 327 to the power 118. So we need to find the answer of this. Now, because our focus is just to find the unit digit, we will not consider these two digits because our focus is just to find the unit digit. So here also we'll not focus on this, we'll focus on this number. So just write a to the power 377 minus 7 to the power 118. Now, what is the rule, guys? The rule is that divide this power by 4. This is a simple rule for all the unit digits. All the unit digits, uh, we have already discussed also that 0, 1, 5, 6 to the power anything like 0 to the power 20, it is 0. 1 to the power 299, that is 1. 5 to the power 355, that is 5. And 6 to the power 199, that is 6. So these are having cyclicity 1. Okay. So the simple rule is accept this. If you remember that, okay, these numbers are having cyclicity 1, then for the rest of the numbers, what you can do, you can just divide the number by 4. So just divide them by 4 and get your results. So let's divide. So for further, if you know the divisibility rule of 4, we know that if the last two digits of any number are divisible by 4, then the complete number is divisible by 4. So here also we have to be very careful that don't divide the complete number, divide the last two digits. So 77 divided by 4. If you divide, so you know that 419 times, and this has to be 76. Okay, one is left. That means, can I say 8 to the power 1? Whatever is left, just write like this, 8 to the power that remainder. Because see, this is the meaning like 8 to the power 76 has gone, and it is 8 to the power 1. Next, 7, 18. Similarly, if you divide this 18 by 4, you know, we get the remainder 2. This is because 4 4 is 16 and 2 is the remainder. So 7 to the power 2. And if you want to write it more, so you can see that 118. So this is 118. That means you can say that 7 to the power 4 has been considered, or you can say 7 to the power even 16, because 4 4s are 16, right? That means this a to the power 4. So if you also check, if you want to check also, you can check that all these numbers, if you write in terms of powers, you will realize what is happening actually. Suppose you write a to the power 1, that is 8. A to the power 2, that is 64. I am only interested in finding the unit digit. A to the power 3, that is 512. A to the power 4, 2 8 is 16, that is 6. Right. And similarly, if you find a to the power 5, so 6 8 is 48. So that is again 8. So what you are observing, this 8 is again coming. And if you find 8 to the power 6, 8 to the 64, this is 4. 8 to the power 7, 4 8s are 32, again 2. 8 to the power 8, that is 8, 2 8s are 16, again 6. So you can see this is repeating. That means I can say the cyclicity of 8 is 4, because the unit digit place is 6, which is repeating after every 4, right? So that means that's why we have divided this by 4. This is the reason, right? Because its cyclicity is 4. So similar for 7 also, if you check 7 to the power 1, 7, and similarly 7 to the power 2, it is 7 to the power 1, 7, 7 to the power 2, 49, 7 to the power 3, that is 343, 7 to the power 4, 2401, 1. Now if you find 7 to the power 5, 1 into 7, 7, see again 7 is coming. So this is the whole cycle which is coming. 7 to the power 7, that is again 3, 7 to the power 8, that is again 1. So that's why I have said that always divide the power by 4, because any number, if something is left, then we take this, and if something is not left, then the last place is the answer. So you can see that if I'm saying a to the power 76, out of this 77, 76 is gone, because it is 19 times. That means it's somewhere like this, that a to the power 76, it is also 6, because it's like this. A to the power 75 has to be 2, this one. A to the power 74 has to be 4, like this. So it is ending here. So we write this 8. Okay. And what is a to the power 1? So you can see 8 6 are 48. So this is coming out to be 8. And the reason is because these powers we don't take normally, because that will not make any impact. If you don't take this also, now you will say it is 8, and this is also 8. So there is no need to use this. That's why we divide the given power by 4, and then we don't check the complete multiple. We check the remaining power, right? So remaining power is 8. Similarly, 7 to the power 16. Similar, you see here also, yeah, it's a big number, but 7 to the power 16 will also end in 1. There is no need to write this, even because this is 1, and 7 square is 9. So I can say that it is 8 and minus 9. Now, many of you may be confused now. Okay, what is this? 8 minus 9? No, guys, because see, this number is more, 568 to the power this. That means obviously this number has to be greater than this number, because it's the base also is less and the power also is less. That means this number is more than this number. That means we have to take the minimum value 8, and then I can subtract 28 minus 9, or maybe 18 minus 9, so like that. So what is my answer? 9. So answer to the question is 9. So this is the concept. Now again I summarize what we have done. So any question comes, divide the power by 4. So if you divide this 77 by 4, 8 to the power 1 is left. If you divide this 18 by 4, 7 to the power 2 is left. What is 8 to the power 1? 8. 7 to the power 2, that is 49, that is this. And you know that this number is more. So that's why at least take 1, or you can take 28 also. Even if you take 28, the answer is same. You can see this is 9, and this is 19. Even if you take 38, that has to be again 29. So the answer of the question in every case is 9. So this is the concept for unit digit. Divide the powers by 4. Okay. On multiplying a number by 7, the product is a number, each of whose digits is 3. The smallest such number is, right? So take a number and you multiply that by 7, and it is saying the answer is like all the 3 are there actually. Whatever number of digits are there, like you can see all the numbers here. So it has to be all 3. Okay, whenever you multiply with any number by 7, and the answer is all 3. So let's check this by option directly. So let's take the first. If you divide multiply this by 7, so if you see 9 7s are 63, 6 carry, 7 1s are 7 plus 6 13, 1 carry, I'll cancel it. 7 6 are 42 plus 1 43, again 4 carry. 7 7s are 49, 49 plus 4, again 53, 5 carry. 7 4s are 28 plus 5 33. So that means this is my answer, because all the results, all the numbers are 3, and that is my answer. Even if you check the second option, you may stuck somewhere. See, 9 7s are 63, fine. 7 plus 6, 13, find 1. Now 7 7 is 49 plus 150. So this is not ending with 3. So this is not the option. Similarly, you can check also here also. 19 7s are 133, 1 carry. 7 6 are 42 plus 143. Yeah, this is maybe close. So let's check this further. 7 8 are 56 plus 460. Again, it is not getting 3 here. Similarly, into 7, if you do this, obviously if you have got the answer already, so there is no need to check ahead. The problem comes when this option is given in the fourth set, right? Like this in D option. Then we have to be very careful in attempting this. So here you can check 9 7s are 63. 7 4s are 28 plus 634. So here also only we are miscommunicating this. So the answer of the question is option A. Okay. Now we have a percentage based question. It is said 60%. So find the fraction value of 60% first. So it is like any percentage. Suppose I have given 75%. What is the meaning? Divide this by 100, because percentage means out of what I am having out of 100. So 75% means 75 by 100. So the rule is, whenever any number is given in percentage, divide that by 100 to get the result in a fraction form. This is called fraction form, and this is called percentage form, right? This is called percentage form. So use this result. 60% is actually 3 by 5. If you solve this, off means multiply. Here also 3 by 5. Let's say the number is n, and is means equals to, that is 36. So I guess you can solve this. 23s are 25s are, and you see 3 3s are 9, 9 4s are 36. So if you want to find n, this 5 will go here. So it has to be 4 into 5 and into 5. So 25 4s are 100. The value of n is 100, students. So what is asked now? Read what is asked. It is saying the 70% of a number. So if I have got a number as 100, what is 70%? I have just discussed this. 70% means 70 by 100 of 100, because here we are finding 70% of 100. So that has to be 70. And this is my third option, right? So this is the approach of this question. So the next question is, if x and y are the two digits of a number and the number is 653xy, such that this number is divisible by 80. See, 80 is a composite number which can be further broken as 8 into 10. So we need to check the number is divisible by 8, and we need to check the number is divisible by 10. For a number to be divisible by 8, we know that 8 is nothing but 2 to the power 3. That means the last digit of any number, last 3 digits of any number, if they are divisible by 8, then the number is divisible by 8. Let's take 1 0 2 4 8. So there is no need to check the numbers 10. Just check the last 3. So 248. If you divide this by 8, 8 3s are 24, 8 1s are. That means this is divisible. So I can say the complete number is divisible. So there is no need to check the complete number. Okay. So just check the last 3 digits. So this is the concept we are going to use here. And for 10, the last digit has to be 0. Last digit has to be 0. Like 2 4 7 0. So this number is divisible by 10. You can see 10 2s are 20, 4 7, 10 4s are 40, 7 0, 10 7s are 70. So this number is divisible by 10 if the last digit is 0. So we are going to use these two concepts in this question. So let's apply. And we have the options also, so we can take the help of the options as well. All right. So first is, write this number which is given over here. It is 6 5 3xy. 3xy divisible by 80, of course. So first check for 8, or you can say first check for 10. So this has to be 0. Very clear, right? Okay, this is 0. So what is left? Now check with 8. So this number has to be divisible by 8. Now tell, what can be the values of x? If I take this x as 2, that means 8 4s are 32, 0 0. This is perfectly divisible, fine. X can be 2. That is first option. Then the next is 6. Check for 6 as well. If I write 360, where this second term x is 6, so 8 4s are 32. What is left? 40. 8 5s are 40. That means this is 0. That means my answer is A option. Okay, because this is proved here only. If suppose you want to check 4, so check it. 3xy. Because see, there is one more thing. Yeah, we have not checked the sum, so please check. The value of y was this, and this was 2. So 2 plus 0 can be 2, because we need to find the sum. If you remember, we have done like this now. This need to be divisible by 8. So obviously we have first checked that this number is 0. Fine. And this number was 2 ones. So it is not asking the values of x, it is asking the sum. So first y is 0 and x is 2. What is their sum? That is 2. Yeah, this is sum. Okay, yeah. Now it is correct. Second, we have taken this x as 6 also in the question. So it is 8 4s are 32. So this has to be 40. So 8 5s are 40. So x is 6 and y is 0. So the sum is 2 and 6. This is also correct because the y, the second number is 0. So that's why also we have got the answer same. Okay, so answer of the question is A, because of sum. Okay, because of sum, not for the only values. We have taken the sum further and then we have got the answer. Okay, right. The difference of the squares of the two consecutive odd integers. What is integers? Integers means any number which is complete, like 2, 3, 5, right, 7, 8. These are complete. If I say 2 by 3, it is not an integer because it is somewhere 0.66, 0.667. This is a decimal. It is a fraction. So this is not an integer. It's saying the difference of the squares of the two consecutive odd integers is divisible by which of the following integers. So consecutive odd integers. That means the least consecutive integers is say 1. Take the square of it. And the next is 3. So take the difference. That is 9 minus 1. That is 8. So okay, one option is there. Fine. Let's cross check for with some more option. Suppose I take the next consecutive order is 5. 5 square. 5 square is because we need to find the squares, right? So 5 square minus 3 square. Let's check. 5 square is 25. 3 square is 9. It is again 16, which is also divisible by 8. So you can check this is verified everywhere. Consecutive odd integers, 7 square 49. This is 25. So if you check, this is 24, which is also divisible by 8. So the answer of the question is D, which is 8. All right, next. Now we have another question of unit digit. Now we know the rule. Don't consider the complete question, consider the last digit and its power. Okay, and a to the power 3890, and we have already discussed what to do. Check the power divisible by 4. Okay, so 90 by 4. If you divide, it is 88 is gone. You see, 4 2s are 8. Then 1 0. 4 2s are 8. 2 is left. That means I can say that the remainder is 2. That means 8 to the power square is the answer. What is 8 square? 64. That means answer is 4. So we have done this question already, like this type already in the first question. Okay, so please watch that again if you have any doubt. Next, very important, successive division, students. So a number was divided successively in order by 4, 5 and 6. The remainders were respectively 2, 3 and 4, and then you need to find the number. Okay, so please remember the rule for successive division. First is, what is successive division? So suppose I take a number, say 56, okay, and I divide this number by say 3. Okay, now if I divide this number by 3, so there must be some quotient, there must be some remainder. So I'll do it here. Suppose you divide 56 by 3. I'm taking some other example just to make you understand. So 3 1s are 3. Okay, 2 6, 3 8s are 24. That means 18 is the quotient and remainder is 2. So I'll write like this. Okay, 18 is the remainder and 18 is the quotient, remainder is 2. Now I further divide this quotient 18. I further divide this quotient 18, suppose by 5. Okay, so it will be like 5 3s are 15. You divide, you'll get what I'm saying. Divide it. 5 3s are 15. What is left? It is 3. So 5 3s are 15. Remainder is also 3. Now I divide this 3 by 2, suppose, because this is the quotient. So successive division means you are dividing the quotient respectively. Remember, we are dividing the quotients respectively, students. Okay, so now we have a question 3. If I divide this 3 by 2, so 2 ones are 2 and 1 is left, like this. 2 ones are 2, 1 is left. So this is called successive division, where you have divided the number by 3 and you have got a quotient 18. Now you are dividing the quotient by 5. Okay, again you are getting some remainder. Then you are dividing this 5 3s are 15. You are dividing this 3 also by some other number, and then you are getting another quotient, and like so this is going like this, because the least quotient is 1, so I cannot go further. So these 3 are the remainders, and these 3 are the divisors, and these 3 are the this was a number itself. This is question 1, question 2, question 3. This is what question 3, right? So let's apply this method, a beautiful method, to find the answer. So first is write this like this. This is your pattern, so write it like this. So 1 2 3 and 4. Okay, and start the question with the last divisor, not start here. So it has to be like 4 5 6. Okay, and write the respective remainder one line below, right? So if you see 6, if you divide, so it is given that if you divide respectively by 6, so the remainder is 4. So write 4 here and take the quotient as 1. Always remember, take the quotient as 1. It is very easy, very easy. If you take 0, it is a problem. Don't take 0, right? So take 1. Now if 6, see, you know the rule. If 6 is the divisor, right, and 1 is the quotient and 4 is the remainder, can you find this number? Yes, you can. And the rule is this is called divisor, right? So write it like this. This is called your divisor, okay, and this is called quotient, okay, and this is called remainder, and this is called a dividend. We have already discussed this in some of the previous sessions also, though you can say that dividend is divisor into quotient plus remainder. So this is what we mean by this. So can I say Kiju, what is the value of n? N is 6 into 1 plus 4. So can I say this is 10? Yeah. So this is the number 10. You check. If you divide 10 by 6, 6 ones are 6, remainder is 4. So that is what we need to apply here. So 6 into 1, divisor into quotient plus remainder. You know, these are all remainders. So this has to be 6 into 1 plus 4, and that has to be 10. Okay. Now what is the remainder in this case? So I'm writing a line, making a line here. Okay. So this is the remainder. Okay. Now go ahead. This is 10 now. And for 5, the remainder is 3. So write 3 here. Now 5 is the quotient, a divisor, and this 10 is the quotient, the remainder is 3. So can I say 5 into 10? 50 plus 3. So this has to be 5, this into this plus the remainder. So 5 into 10 plus 3, and that has to be 53. I hope this is clear. What is the remainder? It is 2 when we divide it by 4. So for 4 again, what we need to do? Multiply. 4, this is a 4 divisor, 53 quotient, remainder 2. So 4 into 53 plus 2. So 4 into 53 plus 2. Find it. So 4 into 53 plus 2. So do like this, 50 into 4 plus 3 into 4 and plus 2. So 200 plus 12, 212 plus 2, 214. So the answer of the question is 214. And if the, and here you can mention the least such number, that is 214, right? Because there is no number least than this, less than this. So the answer of the question is 214. So this is the approach you need to follow for successive division. A beautiful concept, a beautiful question. All right. Next question. We have a formula. If you remember, it's squares. Although you can add this directly also, but we have a formula. Like I can write this like this. It is 2 square plus 4 square plus 6 square plus up to 20 square. You can add directly if you remember all these squares, but that takes time. So we'll solve like this. I can write, use it, 2 is common. So I can say it is 1 into 2 whole square, right? Then 2 into 2 whole square, because 4 is written like 2 into 2. Then 6 can be written like 2 into 3. Okay. And then I have 8. So it can be written 2 into 4, right? And similarly, up to 2 into 10. I hope this is clear. If this is clear, you can break it further. How? See? Break it further. 1 into 2. So can I say 1 square into 2 square? Because I can take this out. There is a formula like a b to the power n can be written as a to the power n into b to the power n. So I can write like this. Similarly, here also I can write 2 square into 2 square. Here also 2 square into 3 square. Here also 2 square into 4 square. And plus up to 2 square into 10 square. Okay. So next, what is common? What is common? What number you can see everywhere? You can see 2 square is everywhere. So you see, this 2 square is everywhere. It is common everywhere. So I can take that out. 2 square. What is left? What is left? You can see this part is left. 1 square is left. 2 square is left. 3 square is left. So write 1 square plus 2 square plus 3 square plus 4 square. And what is left in the last? It is 10 square. So if you add directly manually, that is also fine, but we have done the formula. So what is 4 square? That is 2 square is 4. Now we know the formula for the square of the first n up to n square from 1. We have a formula. I write it here. That is n into n plus 1 into 2n plus 1 by 6. This is the formula to find the sum of the squares of first n natural numbers. We have done this type also in the previous sessions. So this is the sum of squares, like 1 square plus 2 square plus 3 square up to n square. So that is n into n plus 1 into 2n plus 1 by 6. So apply. What is the value of n here? It is 10. You can equate now. So just use 10. 10 into 10 plus 1 into 2n plus 1. 2 into 10, 20. 20 plus 1, 21. And by 6. Now you just solve and get the answer. 2 2s are 4. 2 3s are 6. Then 3 7s are 21. So what is the answer? 11 7s are 77. And you see 77 10s are 770. So 770, and this 2 is also here. So what is the answer? 1540. You can solve it like this also. 700 into 2 plus 70 into 2. So 700 into 2 is 1400, and this is 140. So this is coming as 1540, and which is your third option, right? So this is the concept for this question. All right, let's move ahead. Now we have a formula, 64 square minus 36 square. So we have done this before as well with some concepts. So see, if you are comfortable in finding square, that is brilliant. That is brilliant. But if you are not, then also we have a formula. We have a square method, which I have already discussed in my previous videos. So 64 square. Suppose you need to find the square of this number. What do? Do like this. Take this number as A, take this number as B. Now, write this number square. So 6 square is 36. And write this number square. It is B. B is 4, so 4 square is 16. And then multiply these 3. And 6 4s are 24, and then double it. So 2 into 6 into 4. That is 2 into A into B. So that is 48. And write 48 leaving one digit from the left, from the right. So this is from the right. So 48 you write like this and add. You can directly get the answer. So just write it. So this is 6, this is 9, this is 10, this is 4. So this is your 64 square. You can write 4096. Similarly, if you want to find 36 square, okay, so this is 3. Now this is A, this is B. So what is the method? Method is write A square and always write in double digit. Never write in single digit. 6 square is 36. Now multiply this. 6 3s are 18. 18 double 36. 6 into 3 18. 18 double 36. So write 36 leaving one digit to the right and write below it and add. Alright, here also we added. So 6 9 and 12. So 1296. So this is 1296. I hope you can solve this now. So this is equal to 20 into U. So what is the result? 0 0 and 2800, I guess. Yeah, and this is 20 times into U. So you can solve this. So 20 20 to 1 4. The value of U is 140. This is one method, right, where you can directly find the squares and get the answer. Second method, if you remember, it is a little easy. If you don't know the squares, A square minus B square, that is equals to A plus B and A minus B. So use this. What is this? It is A square. A here is 64 and B here is 36. This is easy because these numbers addition and subtraction is easy. So 64 plus 36, right? And 64 minus 36, and that is equals to 20 times U. 64 plus 36, 100, and 64 minus 36, it is 28. So similar way, we have got the answer. 28 5s are 25 is 100, 28 5s are 140. So the answer is 140. So you can go either way, right? You can go either way. It's up to you. All right, next question. The last question of the video. Which of the following cannot be the square of a natural number? So square itself is a big important concept. So here, if you find the squares of any number, this I have discussed in the square root video also. Please watch that if you have not. Square root shortcut or squares. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square 49, 8 square 64, 81, 10 square is 0. If you see all of these numbers 1, 4, 9, they are repeating, like 1 is repeating here also in 1 and 9. 4 is repeating also in 2 and 8, right? 3 is repeating, 9 is repeating in 3 and 7. Then 6 is repeating in 6 and 4, and 5 is alone. So these are the numbers which are the unit digit of the perfect squares. First thing. Okay. First thing is this. Second is this. So that means the unit digit, if unit digit is except this, then there is no chance that the number is a perfect square. So just check the last digits here. So if this is 1, yeah, it can be perfect square because the 1 is there in the list. Okay. And then 5, last digit 5, yes, 5 is there also in this list, you can see. 7, yeah, 7 is not there. You can see 7 is not there. That means this is the answer. 4 is there. Yeah, 4 is there. You can see. So this is the first rule for a perfect square. The most important rule. There are some other rules also, digital sum wise also. Like suppose if you see 36. So I explained that rule also. So perfect square digital sum is like 36. What is digital sum? Add their respective digits. So that is 9. So for a perfect square, the digital sum should be 1, 4, 7 and 9. The digital sum, please repeat it. If you're not understood, digital sum, the digit sum, like 36. The 36 is a perfect square. You know, it's for 6. So its digital sum is 9. Okay. And if I say 49, what is the digital sum? 4 plus 9, that is 13. 13 again is a double digit. So break it. 1 plus 3, that is 4. So see, 9 is there, 4 is there. Now take some other number. 2, 56. This is also perfect square. So 2 plus 5, 6. 7 plus 6, 13. Again 4. Now 1 plus 3. So if you take 289, so this is 2 plus 8 plus 9. So this is 19. Right, 19 can be written as 1 plus 9, and that is 10. 10 can be written further as 1 plus 0, that is 1. So 1 is also there, you see. And similarly, if you find squares, you will find 7 also. Like any number you take, suppose you take 576, right? 5 plus 7, 12 plus 6, 18. It is again 9. Right, if you take 1, 2, 2, 5. So 3 plus 2, 5 plus 5, 10, again 1. So this is a rule. And if you check also, 7 also will come in some square root in a perfect square. So this is also you can check in any of these numbers. The first rule is very clear. Second rule is perfect square digital sum is always lying one out of these, 1, 4, 7 or 9. So you can check this. So if you check 3, 2, 7, if you check this number, its perfect square is 6 plus 4, 10 plus 3, 13 plus 7, 20. 20 means 2 plus 0. And we know that perfect square digital sum can be this only. It cannot be except these. So it is 2 here. That means this is the answer. You can check this way also. Or if you see this, 3 plus 2, 5. 5 plus 7, 12 plus 6, 18 plus 19. 19 means 1 plus 9, that is 1. So 1 is there, yes. If you check this, 8 plus 1, 9 plus 2, this is 11, 13 plus 5, 18. 18 means 9. This is there in the list. You can see. This is a number there. If you check this, 2 plus 1, 3. 3 plus 6, 9 plus 4, 13. And 13 means 4. This is there in the list. Right, so every number is there in the list, but this is not. So you can remember the digital sum of the perfect square can only end with 1, 4, 7, 9. So the answer of the question is C. So guys, that's all for the session. I hope you liked it. So thank you so much for watching. God bless you all.